Do you know what a laser is? It is not only a tiny device you can use to play with your adorable cat. Lasers can be found everywhere, from grocery store scanners and printers to security systems in your latest smartphone that enable face recognition. But there are even more innovations ahead of us. Currently, we only have a limited number of materials that can be used to make lasers, and lasers of certain wavelength are still very difficult to manufacture. That's a shame, because without these technologies, we won't unlock applications such as truly immersive displays. But what if I told you there is a new material system we could use to fill the laser color cap? To get a laser, you first need to generate light using an efficient light-emitting diode, or an LED. The color produced by the LED will largely determine the color of the laser you are making. And I'm researching halide perovskites, a class of abundant materials that can be used to make LEDs of different colors. Moreover, the fabrication of these perovskite LEDs is possible even at room temperature without the need for expensive, environment-controlled manufacturing equipment. The way you make such an LED is strikingly similar to assembling your breakfast sandwich, layer by layer. By depositing various layers with different functions, including the perovskite layer that produces light, from liquid solutions, you will eventually get an LED. The chemicals are measured out like the ingredients in a kitchen. You are basically cooking up your LEDs in a lab. Now, connect your finished LED to a battery and let there be light. Finally, to amplify the light and turn your LED into a real laser, add a pair of mirrors and use an even more powerful battery. It sounds simple, but today there are still a lot of scientific and engineering challenges that must be solved to make a working perovskite laser. First, we need to make sure that the backbone of our future lasers, the LED, is very stable and energy efficient. Unfortunately, perovskites are notorious for their instability and decomposition when operated under high power conditions. But the chemical versatility of perovskites can allow scientists to address these challenges in the near future. And with the development of new cheap and efficient perovskite lasers, we will create the displays of science fiction and much more. And that is something I get excited about.